I'm Russ Altman, and today Carlos Guestrin tells us about why it is both important and hard for AI systems to gain the trust of users. He'll tell us that the ingredients that lead to trust between humans can lead to principles for trust between humans and AI. It's the future of trustworthy AI. So, the field of machine learning has exploded in the last 10 years. Computer scientists have learned how to build systems that can analyze images, understand text, drive cars, answer questions, and many other tasks. They generally do this by providing lots of data and allowing the computer to look for the patterns and connections in this data so that given a new example, a new image, a new text, a new driving situation, the AI can use the combined experience in all of those examples to recognize the content and context and decide what to do next. These systems are often only as good as the data they are provided. If the data has been collected broadly, on a wide range of situations and contexts, then the system may reflect this breadth of applicability. However, if the data has been collected narrowly, maybe only certain types of images or certain driving situations, then the system may perform not well in some situations and very well in others. This feature of AI systems has received some attention in the popular press. Many folks are worried that they will be impacted by AI systems that have been trained on narrow data, not in the situations that they find themselves in, and therefore the performance will be bad. This becomes especially important because AI systems are being rolled out for determining financial risk, deciding on credit and loan applications, making health diagnoses, and other activities that can really be important for somebody's life. So it would be natural for folks to ask, how much do I trust this AI system that is making all these decisions? Also, we want the engineers who build these systems to design them from the ground up to have features that would suggest that they were trustworthy. So these engineers have to understand how to do that. Professor Carlos Guestrin is a professor of computer science at Stanford University. Previously, he had been at Apple working on AI systems. His group focuses on challenges in bringing AI into broad use. They are particularly drawn to the more ill-defined challenges that represent barriers to broad AI adoption, such as, for example, how do we learn to trust an AI system in the same way we might trust a healthcare worker? I started the conversation with Carlos by asking him about the current status of AI applications, what has enabled recent advances, and why issues of trust emerge as so important.
It's great to be here, Russ, and I'm really excited about AI and the changes we've seen over the last couple of decades. It's amazing. Each one of us interacts with AI-driven and machine learning-driven systems every day, be on devices that we use, like your phone, your computer, or when we're watching movies, or every day in different places we go, like when we go to the doctor, or even in all sorts of other new domains that are happening around the world. And AI and machine learning is really about computers learning from the world, learning from data that comes from sensors, that comes from how we interact with the web, how we talk to each other in social networks. As computers learn, they can do tasks they've never been able to do before, which is super exciting because some of these are really hard to code. The way it used to be is that a person had to sit down and think about all the possible ways something could happen, all the possible ways that, say, a dog might look like in a movie, or a cat in YouTube videos. And now, by just looking at all this footage of videos, we can automatically detect those best cat moments to share with each other. And the excitement of being able to learn to program machines, or machines learn to do things for us, is really exciting.
Great.
And from my personal perspective, I'm less interested in, let's say, the automation part of AI. How can AI systems do something automatically for us? But I'm really interested in how humans and AIs come together, how we can collaborate to augment each other's capabilities and do things that we haven't been able to do before. And we've experienced this broadly. So, for example, if you think about the web, there's billions of web pages out there. It would be very hard for a human to go and flip through each one of those like we used to do with the index of yellow pages to find the right one for us. I guess some folks are not going to remember yellow pages anymore, but It'd be
I
really
do.
hard to manually do that, but a computer can help us do that really quickly. But a computer doesn't introspect into our heads in a way that they really understand what we're looking for and what our goals are. So that collaboration between the machine and the human, that augmentation of our capabilities is really exciting to me.
Great. Super introduction to how you're thinking about this. And it really actually leads very naturally into my next set of questions, because you're a computer scientist and yet you've been talking and writing a lot about trust. Not perhaps the first thing that somebody would expect a computer scientist to talk and write about. So tell me, why does trust become such a central issue to you? And then how do you use your technical skills to approach it and kind of break it down?
I'm really interested in how that collaboration between humans and machines work. And to do that, we have to trust that those devices, those AIs, have our goals or interests in mind. And I've done a bunch of reading in this respect. And one of the things that have been very influential to me is the work in medicine around trust. So there is the seminal paper from Tom et al. From about 15 years ago, where they said that if you have trust in your provider, then it can improve the quality of your care. It can increase the amount of times you go to take care of preventive services, of surgical treatments, and so on. And there, they analyzed how people really understood their providers, and they divided trust into three aspects. The first one is technical competency. Does this provider, are they good? Do they know what they're doing?
Right.
The second one is interpersonal competency. Can they communicate with me about what they're doing? And the third one, they called agency. Does this provider have my best interests in mind? Are we aligned with each other? And so when I think about an AI and all the risks that we've been talking about as a society of AI, some of these issues all come to mind. Does this AI really know what it's doing? Does it tell me what it's doing? And does it have my best interests in mind? And you can see all sorts of, say, movies that have been talked about where there are issues with AIs and collaboration, and they often have this flavor of breaking down on some of those core issues of trust. And so for me, I've been thinking about a framework of trust in machine learning or AI, where it has three components. The first one I call clarity. Clarity is about the quality being well understood. Does that AI communicate with me well about what it's doing, what its intents are? The second one is about competence. Is it high quality? Is it accurate? Does it know how to do the task? Really, competency is about having sufficient skill for fulfilling a particular task that we have in mind. And the third one that's been tough these days is an issue of alignment. Does the values that this AI strive for or execute on reflect the values that I want to exhibit in a society? Be it kind of personally as a human being or as a company in the products they bring together. So to me, issues of clarity, competency, and alignment are key to gaining trust in the systems we're building. And when I think about trust, I think about it in different ways. So for example, one of it as a developer of systems, as an engineer, do I trust that what I'm building makes sense? Can I trust what I built?
Right.
The second one is maybe you as a user of my system, can you trust what I built?
Right.
And
because then it goes into your motives. Why did you build it in the first place? Are you trying to sell me something, or do you have my best interests in mind?
Exactly. And the third area, of course, is as a society or as a community of AI practitioners and researchers, can we trust what we are building?
Yes.
Are we moving forward in a way that contributes positively to the world, to our society and our values?
Yeah, so this breakdown of trust that you just said, clarity, competence, and I think alignment, it sounds great. And it seems to me that, and it sounds not just great, it sounds like it's what's needed in order for the field to advance without causing major trouble. I guess one of your challenges is, how do you turn this into a set of technical requirements that you and your team can kind of engineer? And so I guess I'm wondering, I don't know if you want to pick one of those areas because they're all very good, but like, how do you turn that goal of clarity? How do you turn that into a research program for a bunch of computer scientists?
Yeah, that's a great question, Russ. And when I talk to incoming PhD students, I have a little speech I give, which I can repeat here because at least I'm entertained by it. There's something called benchmark problems in AI. These are problems that are well established, that folks work on year after year, and they get better and better. I say, it's a lot easier to work on those. You know what the task is. You can find what's called a gradient, right? So you can always get better. You can write papers about it. I'm terrible at that. I'm really bad. Don't come to work with me.
We don't like benchmarks in Carlos's lab.
Yeah, maybe we'll create some benchmarks, but we won't be able to work on those kinds of problems. The problems that I gravitate towards are the ill-defined, hard-to-pose, ephemeral things where when you do it for the first time, you're scratching your head, kind of literally asking yourself, what do we compare against? How this is ever going to get published? And whenever you write a paper, the comments are like, why didn't you try this baseline or that or this? Because, nobody knows what to try. And so I gravitate towards that. So when I think about clarity, competence, and alignment, these are the kinds of problems that are hard to formalize. This goes back to your question, right? So for each one of those, part of the work that we do, maybe a biggest part of the work that we do, is to try to understand, how do you go from issues that are almost social technical to issues that are mathematically founded, that you can methodologically apply techniques to, and typically we tend to write papers that bridge that gap, and then a lot of people tend to do it better afterwards, where they come up with better methods and so on. So, for example, I can go through each one of these and give you some sense of things. But if you talk about clarity, right? So machine learning models have been doing amazingly well, right? There's just issues of neural networks have been gaining popularity after decades of being less popular, and over the last really 10 years have made a huge difference. And these are really complicated models with lots of parameters that take lots of computation. They're almost like a biological system. You build it, it does stuff, you don't know why it did it,
but it seems to work great.
It seems to work great, right? And so what I'm interested in is, why is it working great? And can it tell me something about when it's working, when it's not working? And what we've discovered is that because they're so flexible, because they look at data in such detailed ways, they can often be susceptible to things like spurious correlations, or looking at areas of the data that are not relevant to a decision, but make it look great in the surface.
Right.
So part of the issues that we formalize are, for example, what are the parts of the inputs? Let's say what parts of image were most important to making a decision. And by looking at issues of clarity, like, I looked at this part of the image, recognized that Russ was wearing glasses, and you go back and say, well, that's not Russ's glasses. Right. And so what is it about the image that was important? And can you go back and study the original data set, for example, and realize that there were no red glasses in the data set, and that was one of the issues that came up. And so part of it is kind of creating this human in the loop iteration process that helps you understand what is relevant, what's relevant to a decision, and for whatever application, be it for a medical application, be it for developing better models, how can you close that gap? How can you close that loop?
I'm struck by that because, let's say, you would think it would look at my face and say, I see some glasses, that's why I say he's wearing glasses. But maybe they saw some glass cases lying on my desk, or maybe they saw a book about bad vision, and all these things that actually would be kind of relevant, but would not really be the way you would want it to make the decision. So it strikes me that by seeking the clarity and understanding how it made the decision, it's not only giving you clarity, it also might improve the performance of the machine learning algorithm, because you can kind of teach it not to use features that are misleading or are not really the things you would want it to rely on. So, but really, that's a question. Do you wind up with better machine learning performance when it's also more clear?
Absolutely. So there's something in machine learning called generalization. Generalization is, can a model tackle problems, let's say data inputs that was not similar to what it was using to learn? So learning, we call that training data. What is to train the model? Then generalizations can solve new things that it didn't see before. And what we discover by bringing more transparency is that it can generalize better. Let me give you a very, very specific example. This is less about clarity, it's more about the area of competence. We looked at models of text that make predictions from text data and images. And there was really interesting models. For example, you can look at an image of, let's say, a family eating a dinner and serving it on a tray. This is a real example. And you say, you type in the text, what color is the tray? And it says pink. It's pretty cool, actually. It's related text to images. It's kind of how these models are so exciting and new. But if you change the word color from the American English spelling and you add an extra U to the British English, I'm going to not use a British accent, but you can imagine in your head,
yes.
color of a British accent. Now it says it's a green tray.
Whoa.
And so you ask yourself, when you discover these issues and you illustrate it to a human, I've now created a narrative for you, right? I said, there's the English spelling, but American spelling. The models don't know about English spelling, American spelling of the word color. But what we discover through that process is that in the training data, in the data that's used for this model, there was only American English. So there was never coverage for COLOUR, and thus it never learned the mapping between the two. And so what that leads to is an outer iteration loop where you say, to generalize to the real world, we're going to assume we're going to meet some people from the UK. And so we should be able to broaden the notion of what English is. And so in the process of better understanding models, better exploring when they work and not work, you can have models that generalize better and do better.
This is The Future of Everything with Russ Altman. More with Carlos Guestrin next on SiriusXM Business Radio, channel 132. Welcome back to The Future of Everything. I'm Russ Altman, and I continued my conversation with Carlos Guestrin of Stanford University about his work. In this segment, he described why it is so important, not just for AI, but for all of science, to share computer codes to increase transparency and reproducibility, and therefore trustworthiness of their results. Then we transitioned to his passion for using AI to help healthcare. But to start, I asked him about this idea of open-sourced software, that is, software that's made freely available to others as part of the dissemination of basic research.
Thanks for bringing that up, Russ. So I've been working in machine learning for a long time. In fact, I was mentioning I was a PhD student at Stanford, and I took your class in the late 90s or maybe 2000.
We are very proud.
And things have changed a lot in the last 20 plus years. When I was a grad student, you'd write a paper, you didn't make your code available, the data was not available, it was impossible to compare with each other, it was very hard for people to build on each other's work. What we've seen over the years is a transition to making more and more of your code open source and available with the papers that you do, and then for the field to value the creation of these open source systems. And so for the last, I would say, almost 15 years, maybe more, my group has been creating open source projects. Many of them have had huge adoption. They're used by basically every company in the world. And I'm very excited about that transition, that translation of technology and algorithms and methods into the real world. And the path can be very effective. It can also help the field have more repeatable experiments, can help work build on each other, contribute to joint projects, even for people who don't necessarily collaborate with each other more directly. So it's been very transformational to the field. We've seen a number of these influential projects go on. And I think one of the main outcomes is that it has made machine learning and AI more accessible to more people, which leads to more innovation. We see more apps using machine learning. You see more folks in scientific projects using machine learning and so on because of this open source project. So I feel very proud of that work.
Yeah, so let me ask you about that, because some people might think, oh, he's giving away the farm. So, and of course you have co-inventors. You're not the only one, so you have to get everybody on board. So tell me, is it a hard decision to decide when to go open source? And for example, I know that you've started companies in the past. Did you hold that more closely, or was that even based on open source? I'm just interested in the calculation of when it's right to share and when it's right to not share.
So as a friend of mine, Joel Guestrin from Berkeley, says, the work in computer science is really a team sport. So I think that the issue of, let's say, trying to hold on to IP in computer science, to patents and so on, hasn't been particularly effective over the last several decades. So the decision to go open source, typically really easy. And folks who work with me know that we're going to open source everything that we do. I think that's why we do science. We write papers about it, we put out code, we build on each other's work, we collaborate. I love that process. In terms of building businesses, it turns out that the innovation in the algorithm or the method, the implementation, tends to be a very small component of the whole product. And so when we build successful companies, even though we may have built on some open source projects that came out of my group or some other groups around the world, the thing that made the difference to customers was the entire package. Right. So if you think about extremely popular open source projects for machine learning, so XGBoost from my group, or PyTorch, or TensorFlow, these are perhaps some of the most popular systems out there. I can't think of a company that has made money from that specific bit. Google, TensorFlow, or Facebook with PyTorch, or us with XGBoost. But there are many companies that build products around them, or use them in products. And so I think there is a difference between what I call a project and a product, and that gap is what business is about.
Fantastic.
If you know what I'm saying.
Yeah, that really makes sense, and thank you for that, because that really helps. So in the last 4.5 minutes, I wanted to go to healthcare, obviously something I care about and something that you're active in. So can you tell me what draws you to healthcare, and what are the kind of projects that you find most relevant in your healthcare portfolio?
Yeah, so this is become a passion of mine over the last 10 years or so, and part of it comes from kind of a personal thing of interacting in the world, of having kids, of interacting with the medical system, and getting to learn how some of the decisions that are being made happen, and how some of those are data-driven, and there's great providers. Some of those are based on great intuition, and how as a customer of the system, if I say it that way, how often little knowledge of how difficult it is to make decisions for myself or for my family in the process. And so over the years, based on that experience and based on work that we did at Apple, I've become more and more interested in how to make that process more data-driven. So if you think about issues of trust and how I talked about in the beginning in the medical field, really, I think that the dyad between the provider and the patient, and then you can think about all the other people involved, is a very interesting one. And I think the world is evolving to being more of a data-driven world. So if you look at the New York Times, for example, the front page, every day there's a plot about COVID and how it's going. So we've become more data-driven in our dialogue. And so my personal belief is that if we make that conversation, the delivery of care, the behavior change we're hoping for, more data-driven in its decisions, but also in its communication, we're going to have more adherence to care, better lifestyle changing approaches, and overall better outcomes. So I think a lot about that. As a very specific example, there's a great project on type 1 diabetes from the Stanford Children's Hospital, Lucille Packard Children's Hospital, that I'm part of a collaboration along with some folks in management science and engineering and statistics, where they're looking at using continuous glucose monitors, CGMs. These are patches that measure glucose over time and help deliver better care for kids with type 1 diabetes. And what I'm really interested in is how can you look at that data, that signal of your glucose, and figure out how to match your lifestyle changes with the signals that you get. So for example, if you have a big carb meal, you can have a big spike in your glucose. But if you go for a walk afterwards, that can smooth out and that can lead to better health outcomes. So one thing that I can do is I can tell you, you know what, you should go for a walk after your meal. But another thing that I'm excited about is, can you learn to look at your data and understanding that communication, that here's the spike, here's the less spike, and so you're able to generalize, go back to the issues of generalization talked about earlier, generalize that learnings to other behavior changes you're hoping for if we make the process more data-driven and if we can grow each other in our understanding of the underlying causal mechanisms that lead to better outcomes.
This is a great project, and I noticed that you mentioned the Children's Hospital, and as a physician, I know that teenagers with type 1 diabetes are especially at risk because they like to be rebellious, but rebelling against your insulin dosing is not always a great idea. So I wonder if this might be a way to get them on board. It actually goes full circle back to your issues of trust, because glucose monitoring and glucose management is a very high stakes set of decisions for the patient where the trust is very important. So I'm imagining that these considerations all come into play.
And issues of rebellion in teenage years, that's one piece. But the other thing is everybody's busy, right? And they have lots of interests and there's lots of going on in somebody's lives, right? So you want to figure out how to get somebody's attention in the right times and how to have a collaborative process with trust, obviously, right? So the teenager has to feel like their decisions matter.
Yes.
But also something that understands my schedule, my needs, my data, and helps collaborate with me. It goes back to this issue of augmentation, right? So there's an AI that takes over the world. There's a provider that tells me everything I should do. And then there's a collaborative process for augmenting each other. And I think that this analogy holds true also in the example we're talking about. So I'm excited about data, and I'm excited about how communication can be more data-driven in general.
Thanks to Carlos Guestrin. That was the future of trustworthy AI. You have been listening to The Future of Everything with Russ Altman on Sirius XM Business Channel 132.